Bonjour tout le monde, je suis Emmanuel Ameisen et vous écoutez le podcast MLOps, le meilleur podcast de machine learning du monde.
What's happening, Adam? How you doing, man?
Very good, very good. How are you?
I am trying very hard not to make the joke about what your last name means. That is how I am doing right now.
I mean, I
I think
don't mind.
people are sick of it. It's just I basically insert random animal and random country and say that is what your last name means. If it is an animal that has to do with the mar or the ocean, even better. But anyway, we're here today. We just got off this podcast with Emmanuel Ameisen, who, wow, he blew me away. I don't know about you.
I think wowzers is the word. Yeah, definitely.
All right, so some top takeaways from you, and then I'll give you mine.
Yeah, obviously. So, wrote the book on machine learning powered applications. I wrote a book, which is very favorably reviewed. He obviously knows his stuff, and he's at that end of the kind of MLOps space where he's worked in really quite mature organizations. That's quite interesting. Lots of interesting takes on how to go from the clunky, hard, like how do you get value out of the model sort of process to flying, right?
Yeah.
And like the hard work, like hard yards put in to go from that starting point to where we kind of all want to be, which is really quite cool. And yeah, just quite a pragmatic approach to things, actually, like how to align your metrics to get value and how to do things properly.
Yeah.
I think was the big ones for me.
It's funny you mentioned that because it was very much like, okay, this isn't really the 0 to 1 phase. This is more like the 1 to infinity phase that he is trying to fine tune right now at Stripe. He's doing an incredible job. And I think probably one of the best quotes that I've heard in a while was before we actually started recording, he mentioned you develop operational excellence by exercising it. And then I asked him to go into it. He goes hard at what that means and how he implements it. I just loved it, man. So
Yeah.
let's jump into this. Before we do, I will mention there's a little bit of a side. Before we jump into this, there's all kinds of things I want to actually announce. One is that we've got all kinds of cool swag on our shop on the website. Go check it out. Adam's baby has been wearing it. It's our best model
Bang
yet.
Bros.
It's incredible to see. We've got baby clothes, but we also have big kids clothes and big humans clothes. And the next thing I will mention is that we're looking for people to help us take some of these podcasts and choose where the best parts of the podcast are, and then we can create snippets out of them and basically make a highlight reel for those who don't have time to listen to the whole podcast and just want the quick and dirty best of podcast. So if you are up for telling us your favorite snippets of the podcast episodes, get in touch with me because we would love to have you help out. And that's it. Let's jump into this conversation with Emmanuel. Yeah, man. Let's talk about your book, like building machine learning powered applications. What inspired you to write this?
Yeah, I used to work at a company called Insight Data Science. I joined it after being a data scientist myself for a bit. And that company, the whole goal was machine learning education, and more specifically, like professional education. So teaching people, how to actually do machine learning in a corporate setting to actually deliver value and then get hired for it. And so the way it worked is we would lead projects with people that wanted to get hired as machine learning engineers and data scientists, oftentimes applied projects in partnership with companies. And we'd like build a machine learning application to do like text classification, like email classification for support tickets, or computer vision, or even reinforcement learning. Like we kind of like would touch a broad range of applications. And I started seeing that the failure modes of all of those applications, that the ways in which things would go wrong, actually had a lot more in common than I thought. Initially, I thought maybe that like every machine learning application was its special jewel, and then I realized that no, like success criteria and failure criteria are pretty pretty consistent across the board, or at least in some ways. And so um, that felt interesting. And so that's why I wanted to write about that. Before I started writing, I saw that there wasn't much being written about it. So that was further motivation. I was like, oh, this is an interesting topic. And also like I can't find, resources. So I'm going to try to dig.
I always find it fascinating, like when you talk to people that have written books, because it's such an undertaking writing a document that size. How did you find the writing process? Like, how did you go about starting as well? Did you start writing and then find a publisher? And what would be the next book you'd write?
Oh man. Okay. How did I start writing? I'll start there because I feel like I didn't really. Well, I always wanted to write a book eventually at some point, but I didn't want it. I didn't want it then. What happened was I was actually getting uh, pretty frustrated with NLP projects and how one like they all tended to look the same, the successful ones, and two, everybody always wanted to over-engineer them. This was like 3 or 4 years ago, and it was kind of like it was wonderful because for most NLP projects, you can do, natural language processing projects, that is, you can do stuff that's pretty simple and get just amazing value immediately. But everybody was excited about sort of like incredibly complex architectures. And so I wrote this blog post, I don't even remember what it was called. It was something like how to solve 95% of NLP problems. And it was like a tutorial of like, you just do this and then you do this. And then if that doesn't work, you do that. And then if that doesn't work, you do that. And it was based on literally, like dozens and dozens of NLP projects and just seeing them succeed and fail. And that blog post just took off. Like I think, now it probably has like 500,000 reads or something. Like it's just like people just like really liked it. And O'Reilly, the technical publisher, actually reached out to me and they were
Wow,
like, "Hey, we love your blog post. Like, do you want to write a book?" And so that's how I wrote.
really
That's
cool.
how I got started writing. Yeah.
And
Um,
do you think, just before you tell us what your next book will be, do you think it's changed since then? Like, do people still want to over engineer NLP?
I think yes and no. So I think w what's cool about ML is that it is a field that's evolving fast, and so like the kind of easy, hey, just do this. Don't do the complicated thing. Just do this. Um, that solution gets more elaborate as time goes on. Maybe initially, to give you an example, you'd say, think like 10 years ago, you'd say, oh, you want to do, review classification or something. Just do like something called TF-IDF, like do counts on words, like have some version for each sentence. You like kind of count the words, count the recurrences, and then you train a classifier, and that's fine, that'll work. And then maybe 5 years later, papers like Word to Vec and stuff like that came out where you could actually download pre-trained embeddings that were really good. And it was like, oh, like don't train your own model, just like download these embeddings and just use them as is. Like it'll take you like an hour. It's easy. And now I think we're not exactly there yet, I would say, but we're slowly getting to the point where maybe that version is like, oh, just have an API call to OpenAI or some service, and like they'll just like they have like deep models that you can just kind of use. Um, so that's changed. But what I feel like has always remained true is that machine learning engineers are incredibly good at like self-sabotaging. And whatever the like simple, rational thing that you could do to solve the problem, they're like, no, 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 no. Like I'm gonna build my own like 16-layer thing. First, I'm gonna buy a supercomputer, then I'm gonna like train on it for like 3 months and do this thing. And then you look and you're like, it's been a year, like what have you produced? They're like nothing, but like I burned $100,000 of cloud credits. And like I think somehow we're still always excited about the like fancy stuff. And so as the fancy stuff becomes normal, it becomes boring to us. We're like, oh, I don't care about this anymore. I want the new fancy stuff. So that hasn't changed.
Do you think that's intentional? Like, so I have a bit of a view on that. Years ago, I used to talks about. I used to call it something I probably can't say on a family-friendly podcast, but this idea of CV-driven development was the other one where you get people solving the problem before
Yeah.
we've seen it. Do you think it's intentional, or do you think actually it's just a natural sort of component of the world we work in, where you've got these interesting things? It is technically complicated. It's easy to go to a complex solution.
I think there's a bit of both. There's definitely resume driven development for sure. There's also I think for a while and still now there was this perception. Again, I worked with people that wanted to get a job in machine learning. And so one of the things that maybe they believe is they're like, well, if I want to get a job as a machine learning engineer, I have to find the most complicated ML solution and like implement it. Like I'm not going to get hired because like I took some pre-trained model and used it, for something super useful. I'm going to get hired because I invented, a new type of machine learning model or whatever. And that's not true. In fact, what happens is that people that would get hired would be successful were the ones that were like, hey, like here's what I achieved. Like it doesn't really matter how I do it, how I did it. Almost just like here's what I achieved. But so I think that resume driven development is a part of it. I think the other part of it is this stuff's just cool. Like a lot of folks that work in this industry, me included, are just kind of like they like nerding out on this stuff.
Yeah.
Like if I'm just doing something for fun, again, for sure I'll go for something that's like overkill and complicated because it's fun. And so I think that's like a natural tendency that when you're trying to deliver on impactful and like important projects, you have to fight. Is like really um, ask yourself, how can I make this simpler rather than how can I make this fancier?
So basically, ain't no shame in using a pre-trained model. And really, the idea is getting down to what metrics or how are you moving the needle, and how can you prove that you're moving the needle, which leads nicely into some questions that I wanted to ask you about, like as you're now working at Stripe and you're looking at how your machine learning team is moving the needle, how do you look at like KPIs? How do you attribute things back to the machine learning team? What does that look like? So when you interact with stakeholders, you have some kind of you have something to bring them.
Man, hitting me with the easy questions, huh? Okay.
We've already done this is like year 2 of the podcast, so we already got all the easy ones out of the way.
Crap.
Now you didn't realize should have been on here
Okay.
a year ago. I would have given you the real softballs.
Oh, tough, tough. Well, listen, I feel like there's a few ways to tackle your question. Um, One thing is it's always easier if, and especially in machine learning and engineering in general, but especially machine learning, if you can have whatever you're working on to some number that, the company you work for cares about. In a lot of cases, that number is, some version of revenue. Um, Sometimes it can be other things. It could be cost related. It could be security related. Like, I work on a fraud team, so it's not always obvious to say, we've improved our fraud prevention. How many dollars does that make us? It's not always straightforward. But anyways, I think being able to tie it to that number is important. One of one of my mentors when I was just getting started had this saying that it was really cool, which is like basically write the press release before you start doing the work. Um, and I think that helps a lot in the situations where, like before you're going to pitch some new model or some work to like your manager or try working on something, just write the email you're going to send to the company as you're done with the work. And sometimes you'll realize that email sucks. It'll be like, well, I spent 6 months to build the system, and now, I guess like we're kind of slightly better at doing this thing that, some people care about maybe. And, if that's the email, then just don't work on it. And so I found that that's really helpful if you can, in advance, write the email and be like, wow, this would be really cool. Then kind of motivates that project and helps make sure that you will have something to go to stakeholders with. You've already written it. You just need to execute now.
Not like, yeah, we spent 6 weeks and turns out this is hard.
Yeah, that's right. Well, that's the other thing though, is the other way to handle your question is to just reduce the iteration cycle. Maybe that's one of the ones that you got out of the way with 2 years of running the podcast and many machine learning folks coming up. But like, if there's one thing that's been a constant, I feel like in my career is the shortest iteration cycle wins. Like, and making the iteration cycle shorter will make you win. As much as you can say, like we wasted our time in the last 6 weeks. That's not a great look. But if you're like, hey, I ran an experiment, took me 5 hours, it wasn't good. That's fine. Who cares?
So how do you shorten the iteration cycle? What are some like tricks that you found to do that?
I'm a big fan of automating everything you can. It's hard, especially what I found is that it's hard as companies get more mature and have like, bunch of, you may have like a bunch of business processes or a bunch of like different outcomes that you care about that aren't just like, hey, is this model good? But like also like looking at different slices of traffic, different key users, that sort of stuff. But as much as you can, automating away every single step is really what matters. Like you want to get to the world where there's two different iteration cycles that I think I often think of. Like one is the experimentation cycle. So, get in a world where you want to try a new feature for this important model, or you want to try a new model for this thing. You can get your answers really quickly. And so for that, you kind of want to automate. How do you gather data? How do you like generate your features from the data? How do you train the model? How do you like generate evaluation metrics? Oftentimes when you start a team, these are like 12 different things that you have to do. You maybe have like a checklist. It's like, I'm gonna download this thing, and then you go there and like you pull this branch and you do that thing. And it takes forever. If you do one thing wrong, you have to redo the whole thing. So just kind of automating the glue there in the system. And then one thing that we worked on a lot last year is the iteration cycle of deploying your models, which I think is often kind of maybe not taken care of as early as it should. And so like, how do you make it so that if you have a new cool model, it can just be in production and you're not worried about it, without you spending weeks of work to get it there, or getting woken up at 3 a.m. when you deployed a model and it was terrible. So I think those are the two loops that you kind of shorten.
So that leads to another interesting question I think we had that was, I completely agree. I think that is usually where the big wins lie, and they're the ones that scale, right? They're the things that remove all the barriers to scale and things like that, especially if you're starting out. It can be scary though to do it with like critical stuff, right? And I think it's interesting working in finance because there's a lot of tie-overs in the energy industry. Like we are tied into national critical infrastructure. Basically, we get fined out the wazoo if anything breaks. So automating things and iterating things can get scary, right? So do you have advice for like how you tackle that other than leave it alone and let it creak over in the corner?
Yeah, first option is you just never touch it. Like we deployed this model 8 years ago. The person that deployed it left the company. We haven't touched it. If we ever have to change it, like we'll probably just go bankrupt because we'll break everything.
I've seen that.
Yeah, that's one option. I think so. I actually think that in many ways, automation will make it safer. So I agree with you. So we have kind of like the main model that I work on is the model that powers what's called Stripe Radar, and basically it decides for every transaction on Stripe whether we allow it or block it. And so you can imagine that kind of messing the deployment of that model up is pretty bad, potentially absolutely tragic. And so we have to be pretty careful, not just to make sure that we deploy a good model, but to make sure that, maybe if the model is good on average, like what if it's good on average, but it decides to block all payments to, every podcast provider on Stripe, and like it's just a small enough slice that we didn't notice it. That would be really, really bad. And so there's a lot of failure modes. But I think automating a lot of things ended up making it a lot safer, because what happens when you have a lot of failure modes and a lot of kind of like things to think about is that they get distilled in the team knowledge. And it's like, oh, Adam knows about like this particular thing. Like make sure that you ask him, because you have to run this like one analysis. I don't really remember. It's based on this query that's kind of broken, but last time we didn't run it, something went wrong. And then like, oh, and this thing happens. And like you have a bunch of like kind of like weird tribal knowledge. And if any of it goes wrong or goes stale for any reason, everything goes to hell. And so I think automation is safer. The other thing I'll say is like you asked actually like how do you do it? One thing that we found really helpful is before you automate, you suggest. It's kind of the motto, and that works for machine learning too. So let's say that when you deploy machine learning models, usually you deploy them with a threshold. You say, or like depends, but classifiers. You might say, like for fraud, anything above this score is a positive or a negative. Maybe you want to select that threshold automatically, but you're not too sure. And so initially, You write your automation, and all you do is you have a human in the loop, and you suggest that value to them, and you do that over a few cycles. And once for a few cycles, they said like, yeah, actually, I never change it. It's always good. Then you feel more comfortable automating.
I saw, yeah, I completely, for some of the big critical stuff like that, where it's possible. As when I worked in insurance, that was the kind of the only approach. Like people weren't confident in taking their hands off the controls, and I kind of got to the point where I thought maybe that's the only way to do this. Actually, let's not think about full automation just yet. I find it really interesting, actually, the going off piece a bit here, but how similar your language and the way you're talking about doing this stuff, and especially around failure modes, aligns with the chat that we had with Mohammed Al-Gendi a few weeks back, because he talked about really similar stuff and that idea of failure modes. It's really interesting to hear. Like,
Yeah.
Demetrius and I spoke about building cultures of ML and testing and that, but he says that and actually identifying failure modes and trying to do that. It's just I think really certainly something to check out. That similar lines of thought and thinking there is obviously the right approach.
Yeah, I feel like there's like a common thread in operational work, right? Where you think to succeed, you just obsess about the potential failures and reducing their likelihood.
So can we dive in for a moment to what like your actual infra looks like at Stripe and how things are going there, like the nitty gritty of it, and like I guess we can start off maybe before you can give us a little background of what you're working with, but really like you've been at Stripe for a while, and I imagine you, as you mentioned, you've been iterating quite a bit. So like, how has the iteration looked from the infrastructure side? Like, what have you seen? Like you mentioned in the beginning when you got there, potentially there were 13 steps on data collection. I imagine you've cut that down a little bit or you automated it so it's not as painful. Like what were the low-hanging fruits when you iterated on some of the stuff in your specific use case?
Yeah. So we started from a pretty privileged place, I would say, because Stripe is maybe well, certainly a larger company than the median company, I guess, statistically speaking. And so what that means is like there's a lot of infra. So we have kind of compute infrastructure, um, and also batch compute infrastructure, meaning like we have teams that kind of handle think orchestration tools and infrastructure like Airflow. We have teams that handle a model training and serving service where you can train a model and kind of like with one API call have that model be or one function call, have that model be an API that you can call live. So when you deploy your model, like that's kind of like happens magically for you. We have a feature team, a feature computation team that kind of has a framework where you can define your features offline, and then once you define them once offline, they're available to you online. These are pretty gnarly problems that I think I'm pretty happy that we don't have to solve on our team. So that's always been a tremendous help. I would say that so for context, the last year we spent actually focusing quite a bit on reducing both of those feedback loops, kind of like prototyping and deployment, and almost all of it on the prototyping side ended up being on both sides ended up being in these layers of glue that I mentioned, where it's like, maybe, so let me give you an example. Like, let's say, you have a new feature, you've tried it, it helps the model a lot, you want to deploy it. You'll have to, so first you like, got a notebook somewhere, trained your model with a new feature, you saw it was better. Then you'll have to get that code and merge it to like our production code without breaking it, like production training code. And like that code will then train a model. Once you have that model, you'll have to then score it in a bunch of tasks against our current production model to compare it again, because we talked about there's kind of like a bunch of different slices of the world that you would want to compare. So, you use like, let's say like ad hoc Airflow jobs to score, and we're talking about millions and millions and millions of charges, like expensive jobs over time. Then once you've scored all these, you're going to have to run your analysis on it. So you have a notebook, you have some queries, you some SQL, you do analysis. Then what happens is at Stripe, we don't deploy for this particular model. We actually customize the model for large users, and the way we do so is like mainly by, at least initially, like customizing the actioning threshold. And so for hundreds and hundreds of users, we decide on a different actioning threshold. And so that means that you have to do your analysis for this, and you're like trying to figure out, which threshold. And then finally, you think, oh, I'm ready. And you do something which is called a shadow deployment, which we can go into, but it's a very useful process, where again, we can rely on infrastructure there that we have. And then you monitor this manually. And then if this looks good, you say, okay, let's slowly ramp up traffic to production. And then once you deploy it for a few weeks or months, like you'll want to also keep an eye on it because maybe there's something wrong. And so you take a look at performance. And basically, that's the process. And I'll stop in just a short bit, but what I want to say is like everything we did last year was just automating all of this. And so it's kind of unglamorous work, in many ways, where you're just like going in the guts of your system. And you're just like, okay, like this job does this thing, that job does this thing, and then a human does this. Like, can we systematize all of it, make those processes just like directly connect to each other, and like define in code what the human was doing, when they were looking at two curves and be like, yeah, it looks good to me. So that was, a lot of it was just doing that.
It's such valuable work though. Like I totally, and I think it's one of the things that people trying to bake machine learning into their product or platform, like don't understand actually how complicated and kind of unknowable that path is, because that path you've described there sounds right for Stripe and what you're doing, but it'll be completely different from the next organization, like,
Yeah.
because it's context specific, right? And people come in with their own thoughts and ideas, and actually common knowledge and the consensus is changing so rapidly. Did you have to do any of that kind of path trailblazing type stuff yourself, or was it quite a natural fit for where you were going for Stripe?
Sorry, what do you mean exactly?
Well, I mean, like, so how much of that like was quite apparent that these are the steps we have to take to deploy it this way, and these are the tests, and how much of it was actually going out on a limb and trying things?
Oh yeah, a, a lot of it. I think you learn, by trying to deploy maybe without doing one of these steps. You're like, okay, well, we're gonna just deploy a machine learning model, and then, you get to this point where you're like, well, do we know that we didn't completely break, the specific, like, are we just rolling the dice here? And you're like, okay, well, I guess we should do like this one, analysis, and then you do it, and you're like, okay, I'm pretty confident in this, and then you're like, well, okay, so we know that we haven't broken this user, but then you're like, what about this other use case? Like, is this, something that we've taken into account? And I think so. I think two things. One of the reasons I joined Stripe, one of the reasons I really enjoyed working on this is like, this is a problem you only have if you're really successful. So it's a good problem to have. Like, we have this problem because, there are, a bunch of different users, using our APIs, every day in a variety of ways. And so that's a great problem to have, that we have to like think about all of these different use cases and do it. We have all these business processes. And the other thing that I feel like I've become more of a zealot about after doing this work is basically the work that we ended up doing this year was encoding our business expectations in code, essentially, for lack of a better phrasing. And so what that means is usually there's a lot of arcane stuff that goes in machine learning, and it's like, oh, you train this model and then like you do whatever, like some stuff, you do some analysis, kind of whatever that means, and then you deploy it. And so instead it was like, no, when we have this model, here's the contract we have. The contract we have is that, we won't change the rate of actioning of, like charges on this specific whatever country or like by more than this rate. If it's more than this rate, then we'll change it. And then we also like always will move towards like having, let's say like the same, this is just an example, but the same false positive rate and a higher recall. We'll never trade false positive rate down. We'll always improve recall, that sort of stuff. And that's really the key there for us.
So, a few things. First one, awesome vocab word that you said, zealot. That I haven't heard that word in a while, and it made me think, oh, I need to incorporate that into my speech more. The other thing is that you mentioned before we got on here this phrase, which was already a quote, and I was like, oh man, we got to get you saying that when we're on the podcast because I want to make a T-shirt out of it. And it's you develop operational excellence by exercising it. And that what you just said is basically that, if I'm not mistaken. But can we go deeper into that quote of yours?
Yeah. Um, so, so essentially, uh, the maybe the clearest example I have for this is again like releasing models. Um, so here's how most machine learning teams I've been on will go about releasing models. They'll have a new use case. They'll think of a model. They'll you know make the model. They'll be happy with it. They'll release it. Eventually, sometime between weeks and years later, somebody will say like, "Oh, we should release a new version of this model," and then in comes the problem, right? Like the code they used to train the model is way out of date, doesn't work anymore. The data, nobody knows where it is. The release criteria again are in existence, so you're just kind of like looking at what the model does today and being like, well, like it looks similar. Um, and so you end up in this problem that I've had multiple times in my career where you're kind of like doing this reverse archaeology to figure it out. And so, that's because again, you haven't exercised your release pipeline. You did it once. But what ends up happening is even if you do this exercise twice, so you release the model once and then you did it again, um, what I found is that as long as there's enough time between when you're releasing this model, your code will rot just because code naturally rots. And so like whatever you're building, even if it's very smart and very fancy and you're like, oh, I've mathematically solved how to set whatever parameters for this model. It's like, yeah, sure. But all of the assumptions that you had about the world broke. Like when you created this pipeline, maybe your company only operated in this country. Now it operates in 12 countries. So all of your assumptions are wrong. Like all the distributions are different, all that stuff. And so really the only way that you can like have your models retrained and re-released recently, which for many applications is a gigantic boost in performance that you would be foolish to leave on the ground, is to have like that pipeline, that operational work of releasing a model be at least as frequent as like essentially the data demands you to be. And so basically, once you get to that point where, maybe like automatically you're going through this whole process every week or every 2 weeks, the issues that happen at like a 2 week granularity are small enough that you can fix them. It'll be like, oh, like we changed this one thing, so like I'm gonna change this thing, and then it's like it's fine. And so like your pipeline will only like it'll break in terms of like small cracks, and you'll fix the small cracks. It's kind of like cleaning regularly, right? Or like doing housework regularly. Like you fix a small thing, there's a small here. But if you leave it for a year, you come back to it and it's like a haunted mansion, like nothing, like just like the ceilings falling on your face, like, and you just give up, you burn it all down and you build a new house. And so it's all about, I think, doing that frequently enough so that you don't end up in the haunted mansion scenario, and you can just like regularly exercise the work and regularly just like touch it up, and it becomes kind of almost like a Marie Kondo like Zen like thing rather than a nightmare.
Oh, that's so good, man. That's brilliant to think about. And do you feel like ever though that you get the death of a thousand cuts because you're continually like doing all this small work and you're like, how can I get out of this painful like patching up these little cracks? Or is that just part of it?
Yeah, I was going to kind of similarly, like, how do you ever struggle with the balance of that work versus doing like new stuff that isn't that kind of productionization piece? Is that balance hard to find?
Yeah, I mean, I think some of it is, you know, maybe you have to be the kind of person that likes tending to your garden, and like trimming the weeds and all that stuff. But
Yeah, the
there's
constant
also,
gardener.
um, I think what happens is that everything is always like a prioritization exercise. And so for this stuff, like to take the example of our pipelines, that's right. There are essentially, we document this pretty well, like you just like Demetrius, you just released a model, like what went well, what went wrong, like did anything break, and then I'll just stack my kit. We'll be like, okay, well this thing, there's this bug, like you have a 1 in 10 chance that like this kind of like annoying thing happens, but it's not dangerous. It's kind of annoying. It would take a week to solve. We have more important stuff to do, and so some of that stuff we'll just decide not to do. And then some of the stuff is like, no, like this, could, cause a big issue. Like maybe, in some cases we actually get the wrong performance metrics. Like, no, we have to solve this. And so you prioritize that above doing, new work. But again, it's you can always bring it back to like, is this worth more than me building a new model for this other thing? And then you make your decision that way. One thing I'll say that this is maybe now I'm just becoming superstitious, but when we were doing a lot of this foundational work, 4 times I found a small thing, and I was like, oh, this is kind of annoying. It's a small thing, but it's not worth our time to fix it. And the same thing 2 months later ended up causing like just a huge issue every time. And so I've become kind of like way more of a stickler, being like, yeah, it's a small thing, but if I can, I'll just do it. I don't know if that's rational. It's just that I kind of got, the just unlucky breaks 4 times in a row on small things becoming big things. So I guess you develop your own heuristics.
Yeah. That's
I
so
think there's
good.
something about being in the mind space, like at the time, and thinking, right, well, I'm thinking about this now, so let's just fix it, as opposed to trying to resurrect
Yes.
your thinking.
Also, so along the lines of the way that you do reproducibility, like you mentioned this, how much of a headache it is for a lot of people out there and all the teams that you had been on previously, where you have to figure out like, all right, I want to go and get a better model. Let's see, what data was this trained on? What code was this trained on? Where did we get this data? How did we clean it? All that stuff that goes into trying to reproduce the same results. How do you go about that now?
Yeah. So I can maybe go a little bit more into kind of the Stripe tooling around it, because I think it's really good, and we have some blog posts uh, on our engineering blog about it. But I think there's a few things that you kind of want. Like one, you want your data generation to be, yeah, something that you can rerun. And so honestly, that can be as simple as, if you are going to train a model, it has to be attached to a Spark job, ideally that runs in a scheduled manner. Again, because if you just have like, hey, I wrote this Spark job 2 years ago, just rerun it, then I guarantee you that if you try, it'll break. Like the assumptions are all messed up. And so like if you can have, something that generates your training set every week, even if you don't use it, it's fine, and that will, alert you if it breaks, then that's really nice. So that's something that I think is accessible for kind of most companies. Just have doesn't have to be Spark, but have some like data job just keeps running, keeps making your training set. Um, and ideally you do some simple testing on it, nothing crazy, but just test that it's not all empty, or that you don't just have like only one kind of label. Then the other thing that we have that helps with this is, we do the same thing for our training workflows. And so for our training workflows are essentially like, think of it as similar to like a scikit-learn model. Um, it sits on top of the data generation job, and basically everything is defined either in Python or like in a JSON config, telling you like, you take the data, you filter out these 3 rows, you like the label is defined this way, like you take this column and you like multiply it by 3 and like whatever. And you train the model with these parameters, this much, either like this many months of data for train, but also this many months of data for test. And you have the same workflow for like model evaluation, where it's like, cool, you take the results of the previous workflow and you just do a bunch of stuff on it. As we get through more complicated use cases, we extend this by just adding more essentially scheduled jobs. So like for us, we'll have like scheduled jobs that take like yes, we've trained this model, we've tested it, it looks good in terms of like general performance, but now we want to like take the actual binary score, let's say like, I don't know, a bunch of, I'm French, so like a bunch of French charges, and compare how it does to the previous model, and like verify that, in France, this specific condition is met. And then we do a bunch of things. But essentially what I'm trying to say is like, all of this is just scheduled, and it runs whether we deploy models or not. And if it breaks, we know it. And so kind of like extending that to all models. This is something that you can build at kind of like a platform level where you just say like for every data science to the company, you want to like ship a model, you have to have, this job that creates your data. It just keeps like, you just write the job and then like your model training just keeps running, is super helpful because then like you just have it by default and it's maybe like 50% more work when you do your initial model, but then you get, you kind of get away from this huge problem scot-free after that.
Yeah, it's an interesting approach there because I suppose I've not thought of it like that. But you kind of like artificially creating users for your pipelines so that you can then just treat them like you would any other software product, right? You just go, right, well, yep, user raises a bug and need to go fix it, which is quite cool. As opposed to going, right, this thing works, put it on the shelf and let it collect dust and fall over when I next try and need it. It's quite an interesting idea that I've not, maybe it's just my lack of reading, but I've not thought of that.
Yeah, I haven't seen much writing about it either. So, but yeah, I think yeah, it protects you from exactly what you called out, right? Where right now, I think one of the biggest risks of ML is the stakeholder that made the ML model oftentimes is not around and nobody understands anything when it breaks. And so that kind of like is a forcing function because now it's not, maybe you built the model and the pipelines, but now like usually the ownership is at a team level. So it's like, yeah, like, but the team now owns the pipeline that trains and evaluates this model. And so they keep owning it as long as the model's in production.
Yeah, because it's that the different. I always think that the tricky bit comes from things like the static artifact of like the data set that train the model can easily get forgotten. Not so much the model itself might be fine, but the actual artifacts that hang
Yeah.
off of it. Yeah, that's cool. That's cool. I like that. Think about that.
Yeah,
one.
it's incredible. This has been so insightful, man. And I just want to call out everyone who has not read your book. Go and get that. You can buy it from O'Reilly Media or Amazon. And I think they probably have that like where you do the 30 days free trial with O'Reilly. I know they do that a lot. And so if you want to go read the book and those free 30 days, if you're really cheap, go do it. Get after it. The book is called Building Machine Learning Powered Applications. Emmanuel, or Manu, if I got that right with my French,
That's
my
right.
poor French accent. I appreciate you coming on here so much, man. It's been really enlightening. There's so many key takeaways that I've had from this chat. Like just thinking about from the beginning, you were dropping bombs. Machine learning engineers are extremely good at self-sabotage. We all know that, and trying to overcomplicate things. And I think that's just an engineering thing in general. But with all the different shiny tools and new frameworks and PyLightning or whatever the last PyTorch thing that just came out yesterday, I can't remember the name, but we all want to try it, right? And maybe we don't need to for our use case. Like, let's bring it back to the KPIs and let's bring it back to the stakeholders and actually move the needle. Then this was a great one from your mentor. Write the press release before you start doing the work. And make sure the press release doesn't say, as Adam mentioned, we worked on this for 6 weeks and turns out it was really hard. so we gave up. And also, this was key for me when we're talking about the KPIs and how to interact with stakeholders. Tie whatever you're working on to some number the company cares about. Figure out what number that is. It doesn't have to be revenue specifically, but figure out what the company cares about. Tie whatever you're working on to that and be able to show that you can move the needle on that. We're also going to link to some of the blog posts about your internal tooling at Stripe because I'm sure there's a lot of people that want to go a lot deeper on what you mentioned in this call. And last but not least, and maybe this is all doom and gloom, Adam and I created a fake startup for the MLOps tooling sector while we were listening to you called Haunted Mansion, which is in effect doing exactly what you talked about.
One of the best analogies I've ever heard. I love Haunted Mansion. I'm sorry.
Yeah.
I love that.
The cobwebs and all of that.
Spooky
That's what we're
ghosts.
trying to avoid. But the stakeholder who built the model is not around when it breaks. And I think we've all had to deal with that. We all know that feeling. Last but not least, you develop operational excellence by exercising it. Man, so many good quotes and so many key takeaways here. This was incredible. Thank you so much.
Thank you. This was really fun. Thanks for having me.